Okay, so next part is a generator class. So in the generator class, I am simply going to randomize the transistor and generate the values. So what this generator do? Okay, so randomize the transistor class. So in the generator, first you have to do the randomize the transistor and send those values to driver through mailbox. Okay. So, and remember here, the same mailbox should be used for driver and generator. If you are using a different mailbox, then what will happen? Generator will be placing values into one mailbox and driver will be taking values from another mailbox. It will never get the values. So they must be using the same mailbox. So how can you make sure that both of them are using the same mailbox? Anyone? One memory should be created for the mailbox. So two ways are there. One, pass the mailbox as an argument through any function. So if you are passing them means, so in the environment class, whenever you are calling the generator and driver, you have to make sure that same mailbox is passed. So pass the mailbox as an argument to any function, or declare the mailbox as static. Static means only one memory will be created for the mailbox. So it's up to you, whatever you can use. Okay. So class generator, so transistor TR, then mailbox. This is my generator mailbox. Let G1. Okay. So function new. Here I will be passing the mailbox as an argument. Mailbox M1. Then this dot M1 equal to M1. Why I have used this word, this keyword here? Anyone? Why this keyword is used? See, all of these questions you are definitely going to face in the interview. Why this keyword is used?
This will point to the present mailbox.
Okay. Now see, if I am not using this keyword, then what I have to write? M1 equal to M1. Sorry, this is G1, not M1. This G1 equal to G1. So now you just tell me which G1 is belongs to class and which G1 belongs to function. Both of them is sharing the same name. So here tool will get confused. So to avoid this confusion, I am writing this here means tool will understand that this G1 belongs to this mailbox. This G1. Okay, let you here you have given the name as G2. So here you can simply write G2 equal to G1. So here tool will understand that okay, G2 means this variable and G1 means this variable. But if your function argument and the class variable name shares the same name, then tool will get confused. To avoid the confusion, which variable belongs to class, those variable you have to write with this keyword. Understood?
Yes,
okay, so now this part completed, then you have to write the I am writing a task run. Okay, so this is when I am using. So either you use this part. Let you are saying no ma'am, I am going to use the static mailbox. No problem. Static mailbox M1. then here this part it is not required. Because whenever you are creating a memory for generator, you create 10 memory for generator, like you create 10 number of objects for generator, but for this mailbox only one memory will get created because I have declared it as static. So either write static mailbox M1, sorry, G1, or write in this manner. This is the two way. Okay. So next I am going to generate the values. So let task run. Let repeat. Here, but just for now, I am writing 10 values, okay. But I am going to again modify this transactor, this generator class. This is just for your understanding purpose. I am just writing in a simple manner. But here, so many things you can add that I'll be explaining at the end. First, you just learn in simple manner. Repeat 20. Okay. So repeat 20. Begin. Transactor equal to new. I have created the object for them. Then assert transactor dot randomize. I just want to perform 20 write operation, after that 20 read operation. Okay, so with transactor dot write enable equal to 1 and transactor dot read enable equal to 0. So as this is a synchronous FIFO, then I have to make sure that writing and read should not happen at same time, right? So here I can write a constant. Let write read. Write enable is not equal to read enable. So what I am doing here, as it is a synchronous FIFO, then write and read operation should not happen at a time. Right? Either read operation or write operation. If you are going to randomize, there is a chance that write enable equal to 1 and read enable equal to 1. So there it may create problems. I have to make sure that either it is write operation or it is read operation. Okay. Okay. So here I am making sure that 20 write operations. Okay. So after this, I have to put them into a mailbox. So mailbox name is G1 dot, this put function is used in mailbox, then transactor. Here I can call the display function, dr dot display generator. Here it will display me all the values. Okay. Then end. So 20 write operation completed. Then I want to perform let 20 read operation. So for the read operation, I have to make it 0 and I have to make it 1. Okay. So these are the things I'm going to do in generator. What are the signals required? I'm just going to generate inside the generator class. See, after writing this, you guys just go through these things once. If you are facing any difficulties, then in the next class again I will be explaining it. Okay. Maybe in the first attempt you will not be able to understand it, but after this class, just try to go through this code. Okay. So generator class completed. Next part is driver. So in the driver class, I'm just going to drive the values. So class driver. Here I need to transact a TR. Then in the driver, what I need a mailbox and I need an interface. That is virtual interface. Why virtual interface is required? Anyone? Hello.
Virtual interface is dynamic.
See, through the interface, we are going to send the values to DOT. So interface is definitely required. But why virtual interface? As I have already said, interface, it is static in nature. I can't use directly interface in the driver. Driver, it is a class. Class means it's dynamic in nature. So that's why I am just using a virtual interface. Virtual interface means it is just pointing to interface. And virtual interface, it is dynamic in nature. This is also interview question. Why virtual interface? Again, interface, it is static in nature. Driver, it is dynamic in nature. So we cannot use static inside the dynamic. We are going to use virtual interface. It is just pointing to interface. Okay, so again, I have to make sure that this virtual interface is same for monitor as well as driver. So here I have to pass this interface as an argument to driver. As an argument through any function. Okay, so virtual interface here, same should be used for driver as well as monitor. So transact here, then virtual FIFO INTF, let VIF. Okay, and then mailbox name, let I am writing driver D1. Okay, so function new, let okay, here function new mailbox name is driver1, then FIFO interface VIF. I am passing those two as an argument through any function because I have to make sure that driver generator is using same mailbox, driver monitor is using same interface. So this dot D1 equal to D1, this dot VIF equal to VIF, then end function. This is one way. Let you just say, no ma'am, I'm going to use the static mailbox. Then you don't have to pass the mailbox as an argument. So this part I don't require. Okay, so now interface part completed. Now the main function in the driver, task run. Okay, so first I have to wait reset is equal to 0. Then I have to drive the signals. Okay, so here I can add task run begin forever. Why I am writing forever? Because see, in the generator, let it is running for 40 times. I have to make sure that whenever generator part is completed, after that driver should come out of the loop. So it's up to you. You can either write here repeat 40 because generator is generating 40 values, or you can write forever begin, and you have to make sure that whenever generator is generating the values, after that driver should stop driving. So okay, that part will check later. Here I am just writing repeat 40. Why I have written repeat 40? Because generator is generating the values for 40 times. So repeat 40 begin. So I have to first get the values from the generator. So here D1. Okay. See here I don't have to write static mailbox D1. I can directly use here my generator class is okay. Generator class, then scope resolution operator. Their mailbox name is G1.get. Understood? See, this scope resolution operator is used whenever you are using any static variables. So here I am writing that inside the generator class, whoever variable mailbox is G1, from that mailbox get the values. Either this way, or if you are using this way, this manner, then you have to write here D1 dot get transactor. Okay, so this is if you are using static keyword. Now I get the values, then I have to wait for reset is inactivated. So wait VIF dot reset equal to 0. That means I have to wait for reset equal to 0. That means reset is deactivated. Okay. After that, if you want, you can give a delay at the rate passage of VIF dot clock. This delete is again optional. It's up to you. One passage delay is given. Okay, so next you have to pass the signals. Okay, so now what is the my clocking block path? So clocking block path, I guess it is in the mode port. Mode port name is drive dot clocking block name is driver CB. Okay, so now VIF. Okay, so it is VI. Okay, what is my interface name? VIF. See, interface name is VIF. So now go to interface. In the interface, go to mode port drive. Inside the mode port, go to clocking block driver CP. Now inside that clocking block, whatever the variable, write enable. That is equal to transactor dot write enable. So understood this is how I am converting pin level to packet level to pin level. Understood this part, all of you? Go to interface VIF. Inside the interface, go to this mode port. Inside the mode port, go to this clocking block. Inside the clocking block, whatever the signal write enable. This is the signal I am getting from the generator. Assign this signal to this signal. So if you are not using clocking block, you have to write in this manner. At the rate passage of VIF dot clock, VIF dot write enable equal to TR dot write enable. So all of you understood this part? Please respond, guys, whether you are getting it or not.
Yes, ma'am. Yes, ma'am.
Okay. So now when I should pass this signal should be passed only when write enable equal to 1. If write enable equal to 0, then do I have to pass this signal? See, whenever write enable equal to 1, then pass write FIFO related signals. But if write enable is equal to 0, I don't have to pass it. Okay. So here I can write if transactor dot write enable. So if this signal is equal to 1, then only assign those values. If write enable equal to 0, then I have to check whether read enable equal to 1 or not. So if read enable equal to 1, I have to pass the signals related to reading FIFO. I don't have to pass this signal. So this part is done inside the driver. Okay. So the write enable, then I have to pass the data in. So VIF. Okay. Then I have to pass the full signal. Okay. These signals all are related to my write enable. Let you want to pass these signals after 3 clock cycle. Then here you can give 3 clock cycle delay. Now I have to pass the read related signals. So transactor.read enable, if read enable equal to 1, so here I have to check the full signals also, because once I start reading, my full signal may not be 1. Okay, so this is the output. See, this output signal, it is again optional. You can capture inside the driver or you can't capture, it's optional, because output signal we are definitely going to capture inside the monitor. Here I have to take the full signal also. And I have to check the valid signal also. Why I have written full signal and empty signal here? Because once the FIFO is full and I start reading, then FIFO will go to empty. So this full and empty is affected reading and writing in both operations. So that's why I'm writing inside the read operation as well as inside the write operation. If it is not required, then you can not write it. Okay. So valid is equal to t-valid. So this is completed. I have read enable, let out, empty, full, valid. I have written all the signals. Okay. Now here let I want to display what are all the values. I can call transactor dot display driver. Then end task. Then end class. Okay. So this part is important part. Any code, you have to decide, okay, this part is important, because here if you are doing any mistake, then driver will not send the data properly to duty. You are not going to get any valid output. Okay. So guys, this is up to for today class. I'll be sending this part. Okay. And with this, I'll be sending the code link also in EDA playground where it is written. Okay. Up to driver, I have explained. Just go through this. Okay. If I'm sending, then there are so many extra things written. Okay. No problem. Okay. That code I'll send once I'm completing this thing. But before that, just whatever I have explained today, just go through these things. Next class, I maybe take tomorrow or day after tomorrow. There I'll be explaining the monitor scoreboard part. Okay. Okay. And one more thing, guys. Even if you know the things, but still you should know how to write this test bench from scratch. You go to any project. If you are doing the project in SV, these things will be common. Inside it, the logic may change. The logic you have to think, okay, how can I write the logic, how can I pass the signals to duty? But these things like the creating the mailbox, passing the interface, then creating the driver class, writing the transactor class, randomizing the transactor class, these things will be common. Any kind of project you do. Okay. And if you are guys understanding these things, then just go through any like AMBA protocol, either APB or I2C. Try to implement its test bench from scratch. It will really help you in future. Okay. Okay. So this is for today. If you have any doubt, we'll be discussing in next class. Okay. Any doubt or any questions you guys have? Hello.
Hello, ma'am.
Any questions do you guys have?
Actually, where we are writing the data to be returned to the FIFO in test bench, are we writing that?
Which one?
And the data which had to be returned to the FIFO, that where we are writing in the test bench.
I did not get your point.
When we are designing in Verilog test bench, then we giving some data input to be returned to the FIFO.
Okay.
So here where we are giving the data.
See this one, na? I generated the values here inside the generator. Here I have written randomize. So it will randomize, it will generate some right enable. So randomize means it will go to transactor class. In the transactor class, whatever I have written with respect to rand. Rand means randomize function will work on it. So it will randomize some right enable, read enable, and data in. Here I have put the constant that this right enable should be 1. That means it is going to perform 20 write operation. 20 times it is going to make right enable equal to 1. So next what I have done, through the interface, I am passing these values to the duty. I passed write enable, I passed data in, then I am collecting the full also. So these two are my input signals, right? I am passing to duty. Now duty will got the signals and it will generate the output. I am capturing the output in driver, but it is no use. Actually, I am going to capture it inside the monitor, and monitor is going to send to scoreboard for comparison purpose. Okay. Understood?
Okay, thank you, ma'am.
Okay, guys. Okay, bye.
Bye, ma'am.